Hey everybody, this is Larry. This is day 16 of the May Leetcode challenge. Let's get started. Hit the like button, hit the subscribe button, leave a comment, and let me know how you feel. Also, I've got to hit the refresh button as well while you're at it, just so that you get a new prompt. Um, yeah, let me know how you think about this. Odd, even, linked list. All right, let's go. Odd, even, linked list. Given a singly linked list, group all the odd nodes together, followed by all the even nodes. Please note here we're talking about the node number and not the values in the node. You should do it in place. The program should run in O of 1 complexity and O of nodes time complexity. Okay, so that's just O of n, where n is the number of nodes, but they said it over here. Um, the relative order inside both the even and odd groups should remain as it was an input. The first node is considered odd, the second node is even, and so on. Okay. Um, yeah, I mean, I think that seems okay. What I would do now, though the input is a little bit weird, but maybe not. I don't know. Because there's no copy and pasting this input. But I guess I'll try anyway. But yeah, but here I think what I'll do is just start. So first of all, right, the first node would be odd, and the second number is even, and so forth. But what's implicit here means that at most the odd list, if you will be only one longer than the even list. So you can just do it alternating, right? So now I think I'll just start by having a odd node and a even node, and then just combine them at the end. I think that should be good enough. Um, yeah, so let's just say odd is equal to this node, even is equal to this node. Why is my typing a little slow? My computer's a little lagging today. Maybe I have too many things going on. But yeah, and then now let's start with current node is equal to head. Mm, just thinking a little bit through the edge cases because I think we have to keep track of the odd head and the even head later. So let's do that. Um, let's do let's write it this way. Odd head is equal to list node. Odd tail is also equal to odd head. Even head is equal to list node, and even tail is equal to even head. And then current node just equals to head, and then the current parity is equal to 0, say. Or let's start one for odd. The first one is odd, right? Yeah. Yeah, it seems like it. Okay. Because I don't know if it's 0. Oh, yeah. The first node is considered odd. Okay. So then, now we just start with while current node is not none. Okay. If current parity is equal to 1, and you could write this a number of different ways, like counter and stuff like that. But I'm just going to do it this way for now. So odd dot tail is, so now we set the current node is equal to, so that's set next is equal to the current node, and then odd dot, well, odd dot tail is equal to odd dot tail dot next. Um, else, same thing for even, a similar thing for even. And then let's move the node along. Let me double think this for a second. Double check this for a second. Node. Okay, so our node is equal to current node. Okay, I think we might have to Do I have to change something? No, because the next loop will go. But yeah, we'll double check this. I'm not 100% confident about this because they're like maybe dangling next pointers, but yeah. But yeah, now we just have to set odd tail. Oh, I have a typo on the even tail. But odd dot tail dot next is equal to even head, and then now we could just return odd head, right? In theory, because I think we might have some dangling pointers that we have to take care of. What if this is just one? Oh yeah, odd head would begin with 0, so actually odd head dot next in our case. Um, okay, that's slightly better, but still wrong answer. Because I think we have to keep track of the. We have to delete some pointers and keep track of some pointers. Because right now we don't modify the existing point. It's one extra space, so you have to. I think the cleaner way to do it would have been to just create new nodes, but for to keep it all one space, which should be doable. We have to just kind of make sure that this is right. So okay, so the head goes ahead, and then the tail we set next is equal to current node. Okay, and then we look at this. That seems odd. No pun intended. Let's see what happens when we do this. Huh. So, so I think we're just not modifying the next sufficiently. Oh, well, now that part of this also I forgot to change the parity. Oops. Okay. There are different ways to write this, but I'm just gonna write this way. So, yeah, this cycles on the thing because we don't clear out the next. Why do we ever need the next after this? I guess not, right? So let's say last node is equal to current node. Current node, and then now we can maybe set the next is equal to none. Okay, so this is slightly better, and I think this is mostly right. We just that we have to we start our odd head as a placeholder, and we also start our even head as a placeholder. So we actually have to do this. I think that should be okay. Cool. So we're actually pretty okay. I think we had some issues that I think, yeah, when you go through the code, make sure to think about things that could be potential issues, and then when you when you do tests later, you know, see how they could affect it. I just had also had a silly uh, omission, but yeah, let's try some small numbers. Uh, can this be 0 nums? Let's see. I guess it doesn't say, so I guess it could be. Now let's run it again. Looks okay, right? So let's submit. Cool. Yeah, so this is pretty straightforward. And yeah, you just kind of have a list for odds and a list of evens and then put them together at the end. All of this is all one because we only allocate two or three extra things. But only like a constant number of extra variables. We look at each node at most once and make minor justifications, modifications, that is, sorry. So that's all of n times. And yeah, that's all there is. I think this one is a little bit tricky to sometimes to visualize in terms of in your head. So definitely if you're in an interview or even if you're practicing on a computer programming or something like that, have a notebook ready, write out or draw out how you want each link to be, and just go through the steps a little bit of like, okay, well, if I move this to this, then what do the pointers point to in the next iteration? And then that'll help you debug your code one by one in a much easier way than being able to visualize in your head, especially if you're having trouble kind of keeping track of all these things. Sometimes I actually have a notepad right here in case you're wondering. I do have a notepad just for these purposes. Sometimes I use it, sometimes I don't need to. But yeah, um, yeah, I mean, I think this problem comes up a lot on interviews. Not so much on competitive programming, at least not explicitly. But yeah, but still, in a way, these are just like constructive algorithms. These are algorithms that you're like told to do certain things in a certain way and try to make sure that's performant. Um, so it's still a good way to kind of practice your problem solving, even if it's a little bit weird, because no one uses single linked lists. But yeah, cool. That's all I have for this problem. Thanks. Hit the like button, hit the subscribe button, and I will see you later. Bye bye.